All right, so we have a question on AP here. It's a pretty simple question, but we are going to follow um the principle that guides arithmetic progression. So we have that we've been asked to find the sum of the first 20 terms of the arithmetic progression log a, comma log a raised to the power of 2, comma log a raised to the power of 3. So we know that the sum of the nth term of an AP, the sum of the nth term of an AP is usually given as Sn is equals to n over 2 bracket 2a plus n minus 1 bracket d. So this is the formula that guides the sum of the nth term of any arithmetic progression. So that means in using this formula, we need the n, we need a, which is the first term, and we need d. And we know that, so let's start from getting our common difference. Our common difference, which is t, is usually the second term minus the first term. The second term minus the first term. Now, if we're going to do that, our second term from this question is log a raised to power 2 minus log, our first term is log a. Now, if you remember from the law of logarithm, we have that log a minus log b equals log a divided by b. So log a minus log b is equals to log a divided by b. Now, following that principle for this question, that means that log a squared minus log a is the same as log, open a bracket, a squared over a. That's this a squared over a. And that's eventually going to give us log a. So that means that our d, which is the common difference, is equals to log a. Now, we also have that the first term we were given in the question, the first term, which is the first term we were given, is given as log a. So our n is 20 because they asked us to find the sum of the first 20 terms of the AP. So let's just go right into substitutes. So S20 equals 20 over 2 bracket 2a, which is the first term, that's log a. So that's log plus n minus 1, which is 20 minus 1 bracket, our common difference is also log a. So this is 10, open bracket, log a. This 2 is the same as carrying it to the top of a. If you remember from the law of logarithm, if you have log b raised to the power of 3, it is equals to 3 log b. So the power can come to the back, and from the back it can also go to the top of b. So that's what we have here, plus 20 minus 1, that's 19 log a. So from here we have the 10 brackets. This is also the same as log a squared plus, the same thing happens to this 19, it goes to the top, that's a raised to the power of 19. And from here we have that this is the same as 10, open bracket, from the law of logarithm again, this is the same as log a raised to power 2 times a raised to the power of 19. And we have that 10, open bracket, log a raised to the power. According to indices, when you have two bases that are the same, you pick the common base and you add the powers. So this gives 10, open bracket, log a raised to the power of 21. So this is 10 log a raised to the power of 21. Again, these coefficients can also still go up to become log a raised to the power of 21 times 10, because the 10 is supposed to come to the top of a since there is a 21 there. And finally, our answer will be log a raised to the power of 210. So this is our answer. Okay, so we have another question here that says if k plus 1, comma 2k minus 1, comma 3k plus 1 are consecutive terms of a geometric progression. So we've been asked to find the possible values of k. So let's see how we are going to proceed in this question. Now, the wisdom we are going to use to solve this question is that we know that in arithmetic progression, we deal with common difference. But in GP, in geometric progression, what we are dealing with is common ratio. Now, and we also have that common ratio, which is R, is equals to the second term over the first term, which must also be equals to the third term over the second term. So the second term over the first term must also give you the third term over the second term. Now, our first term here is k plus 1, our second term is 2k minus 1, and our third term is 3k plus 1. So let's see how we can proceed in solving this question. So u2, that is 2k minus 1 over k plus 1, which is equals to 3k plus 1 all divided by 2k minus 1. Alright, so from here we can cross multiply and we have 2k minus 1 multiply 2k minus 1 equals to k plus 1 and 3k plus 1. Alright, so if we multiply 2k times 2k is going to give us 4k squared. 2k times minus 1 give us minus 2k. Minus 1 times 2k will give us minus 2k. Minus 1 times minus 1 will give us plus 1 equals k times 3k will give us 3k squared. K times 1 it will give us k. 1 times 3k will give us 3k. And 1 times 1 will give us 1. Alright, so from here we can see that 4k squared minus 2k will give us minus 4k plus 1, which is also equals to 3k squared. K plus 3k is going to give us 4k plus 1. So from here now, we can begin to collect like terms. So if 3k should come to the left hand side, we are going to have 4k squared minus 3k squared. Then if plus 4k on the right hand side comes to the left hand side, we are going to have minus 4, sorry, we're going to have we're going to have minus 4k plus 1 minus 1 equals to 0. Okay. Now from here now, 4k squared minus 3k squared is going to give us k squared minus 4k minus 4k is going to give us minus 8k plus 1 minus 1 is 0, which gives us 0. So from here we can collect the like terms. Sorry, from here we can factor out what is common. Don't know why my video is lagging. It's kind of lagging from my end. So from here now, k is common. We bring out k brackets k minus 8 equals to 0. So we can say k is equals to 0 or k minus 8 equals to 0. So finally k equals to 0 or k is equals to 8. So that's the final answer to the solution. God bless you. Thank you for joining up. I appreciate you. Keep liking and subscribing to the channel. God bless you.